morning. Today we're going to talk about Newton's second law. We talked before in a previous session in Newton's first law, and we said that Newton's first law predicts how objects behave when the net forces are balanced. But today in this session, we're going to talk about when the net forces aren't balanced in Newton's second law. So we can call Newton's second law the law of acceleration because there is a link between the three variables here, the acceleration and the force and the mass, and we're gonna study the relation between the three variables right here. So what is Newton's second law? Newton's second law states that the acceleration of an object depends on two things. First, the mass. Second, the amount of force applied. Let's highlight the definition of Newton's second law here. You can open your book and highlight with me. Highlight the most important variables here, which are acceleration depends on the mass and the force. If I want now to make a link between the three variables here, I can express it in a mathematical formula that is force equal mass multiply a or acceleration, where F stands for force and M stands for mass and A stands for acceleration. So you have to memorize the definition of Newton's second law and how many variables are there and what are the relation between the three variables. Now let's take in another way. You can write the law F equal M into A, where F is force as we said before, which has a unit Newton, M is a mass and have a unit kilogram, and A acceleration and its unit is meter per second square. Okay, we want now to know the relation between the acceleration of an object and the force. As we see in the diagram here, there is a directly proportional between acceleration and force. But if we come to the other two here, the acceleration and mass, it is inversely proportional. What does that mean? It means when force increases, the acceleration increases too, and vice versa. But when mass increases, the acceleration of that object will decrease and vice versa. In a simple language, let's take an example. If that boy gonna push his friend, okay, but with a little force, his friend is gonna move but with a slow motion, or she's gonna move slowly. Why? Cause he gave her a small force. Now we said before there is a directly proportional between the force and the acceleration. So a small force means a small acceleration, a small push means a small moving here. In the opposite way, but if you give your friend a more force, she's gonna give you a more distance, which is mean a more acceleration, because as we said, a directly proportional. Increasing here, decreasing here, decreasing here. Now let's take the relation between the two other variables, which are mass and acceleration. It is inversely proportional. Imagine now you're going to buy something and there is a two shopping cart, okay? One is empty as you see here and one is full of groceries. Okay, now you want to push this empty one, so you will need only a small force to accelerate it. If you're gonna use the same amount of force you use it here in that one, which is heavy, more heavy, you will see that it will accelerate but in a much smaller acceleration even though you use the same amount of force. Because there is inversely proportional. Heavy object mean more mass, mean less acceleration, but a light object mean less mass, mean more acceleration. So at the end, we have to practice the Newton's second law with a problem in your book in your page 36, you can open your book.